So we've got balancing equations set 2, set 2 of like this set, but it's really set 5, where we balance giving words and convert them to chemical equations. Alright, again, you'll need your polyatomic ion sheet, common formulas, your 7 diatomics that I mentioned before. Okay, we covered those a long time ago. And then your periodic table with your oxidation numbers on it. Okay. Alright, and once you get those and you're all set, we're ready to rock and roll. Alright. So we've got element lithium by itself, reacts with gold 3 chloride to produce lithium chloride and gold. So I know lithium, this is an ionic compound consisting of a transition metal and a group 17 nonmetal, and the Roman numeral tells me the oxidation. And then group 17 has a -1, so this is not charged balance, so in order to make it a neutral compound, we're going to have to use subscripts to balance. So AU, Cl, and then I want these to be 3, so I need 3 of these for every one of those to make them cancel. Okay, so remember the swap drop situation. Alright, and then we end up with lithium chloride. Lithium is in group 1, chloride's in group 17, so that is balanced. I don't need to introduce any subscripts. And then good old-fashioned gold. Alright, now we can mass balance using coefficients. So we need to count, and we see we have equal chlorines on both sides, equal golds on both sides, equal lithiums on both sides, equal golds on both sides, but our chlorines are not balanced. So I know I'm going to need to put a coefficient in front of lithium chloride so that I can multiply all of that by 3. So now I have 3 of those and 3 of those. So my chlorides are balanced, but now my lithiums are unbalanced, so I'm going to need to come over here and put a 3. And there we have it, balanced equation. Alright, let's try rubidium iodide reacting with silver 1 nitrate, making silver 1 iodide and rubidium nitrate. So we've got an ionic compound consisting of a group 1 metal, group 17, +1, -1. I don't need any subscripts. Silver transition metal with a polyatomic ion, Roman numeral, so I don't need any subscripts for that one either. Making silver 1 iodide, don't need subscripts for that one. And rubidium nitrate, and we don't need any subscripts for that one. So we need to count to make sure we don't need to introduce any coefficients. 1 rubidium, 1 silver, 1 iodine, and the nitrate didn't break up, and we don't need to do any coefficients, and that's already balanced. Okay, so sorry about this. When I made the font bigger, it spreads it out, and so it's on 2 lines. I apologize. Okay, so sodium phosphate reacting with manganese 2 chloride, making sodium chloride and manganese 2 phosphate. So this is an ionic compound consisting of a group 1 metal and a polyatomic ion. So these are not balanced. So I am going to need subscripts to charge balance. So I need 3 of these for every one of those to make them cancel. Manganese 2 chloride, an ionic compound consisting of transition element and a halogen, +2, -1. This is not balanced. I am going to need subscript to balance that one. Sodium chloride, we know this by heart, hopefully, because it's just salt. Table salt. That's a salt. That's a salt, but table salt. And manganese 2 phosphate. So 2 and 3 are factors of 6. I'm going to need parentheses and then a subscript. Okie dokie, artichoke. Let's see what we got here. 3 and 1. Nope. This didn't break up. 1 and 2, nope, not balanced. 1 and 3, not balanced. And 2 and 1, not balanced. So it looks like we're going to need coefficients for almost everything here. So I need 2 phosphates and 3 sodiums. But if I put a 2 here, I'm going to end up with 6 sodiums. So let's do that. So that does balance my phosphates, but unbalances my sodiums. So I'm going to need a 6 here. Since I have 6 here, I still need 3 manganese and 6 chlorines. So I can put a 3 here, and now I have 3 manganese and 6 chlorines, and we have a balanced equation. And that's probably as hard as they get. Well, take that back. There's a few others that can be a little tricky if you've got elements in multiple places and you have to add them together. That's probably the hardest type. Okay. All right. Let's look at number 4. Lithium carbonate reacts with molybdenum 6 bromide to make molybdenum 6 carbonate and lithium bromide. So all of these are ionic compounds consisting of transition elements, group 1 metals, halogens, and polyatomics. So lithium is in group 1. Carbonate, polyatomic ion, has a -2 charge. So I'm going to need to balance that. I need 2 lithiums for every 1 carbonate. Reacts with molybdenum, and then I look on and see that I have +6 bromide, group 17, so I am going to need 6 of those to produce molybdenum, 6, Roman numeral tells me, carbonate, -2. Interesting. Molybdenum carbonate. So I have 2 of those, and that's 6, so I'm going to need 3 of those. So now I have 6 minus 6. So you see how I did that? 2 times 3 is 6, plus 6 minus 6 equals 0. That cancel. All right, and then lithium bromide. Okay, we're going to need coefficients. I have 3 carbonates, 1 carbonate, didn't break up. I have 2 and 1, 1 and 2. So I'm going to start with the carbonate because that's going to unbalance my lithiums. So now that I have balanced carbonates, but I have 6 lithiums, and I do need 6. Oh, what? Whoa, sorry. I do have a problem with 6 and 2s for some reason. I have no idea why. So I do need 6 bromides. So I know I can do a 6 here, and now we have a balanced equation. Okay. All right, we've got calcium nitrate and reacts with aluminum hydroxide to produce calcium hydroxide and aluminum nitrate. All right, so group 2 polyatomic. So I am going to need parentheses 2 of those, plus 3 minus 1, so I'm going to need parentheses and 3 of those, and then plus 2 minus 1, and I'm going to need parentheses and 2 of those, and plus 3 minus 1, and then I'm going to need parentheses and 3 of those. Okay. Well, metals are all balanced, but polyatomics are not. 2 and 3 and 3 and 2. So you could probably realize if I make them all 6, that should balance everybody, right? So 3 here means 3 here. So 6 of those. So I need what did you tell me? Aluminum, excuse me. Okay. And then I need 6 of those, so I have 2 aluminum, so I'm going to need 2 over here. Okay? Alright, let's look at this next one. Calcium reacts with copper 2 bromide to make calcium bromide and copper. Plus 2 minus 1 plus 2 minus 1. And good old-fashioned copper. All right, we got a balanced equation. Calciums are equal, coppers are equal, bromines are equal. We're done. This one's short and sweet today. All right, potassium reacted with aluminum nitrate to make potassium nitrate and aluminum. Aluminum nitrate. Potassium nitrate. And aluminum. Okay. Metals are balanced, but the polyatomic ion nitrate is not. So I need 3 here. That makes that 3 here. And now we have a balanced equation. Alrighty. We'll do another set tomorrow. Talk to you later.